When you picture a solar farm, you probably see this endless sea of identical panels all just soaking up the sun. But what if I told you they don't all work the same? In this explainer, we're going to dive into a pretty fascinating study that completely challenges a major assumption about how solar energy really works. I mean, just look at this massive solar farm. It's a powerhouse, right? But here's the thing. Deep within this field of green energy, there's a mystery. Are some of these panels, slacking off? And if they are, which ones? And trust me, the answer is going to surprise you. So this all leads to a huge question for solar power. When you're working at this massive scale, how do you make every single panel count? Because when you have thousands of them, even a tiny dip in efficiency, well, that adds up to a massive loss of power. And believe me, the scale we're talking about here is just huge. Take Malaysia, for example. They're on track to have a whopping 4 gigawatts of solar capacity by 2030, mostly from giant farms just like this one. When you're operating at that level, getting the most out of every single square inch is absolutely critical. All right, so let me ask you directly. If you had to put your money on it, which panels in a farm this big do you think perform the worst? Just take a second. What feels like the obvious answer? What's the most likely culprit for dragging down the numbers?
If you guessed the ones in the middle, hey, you're not alone. That's the big idea behind what scientists call the hot middle theory. It makes perfect sense, right? But, as we're about to find out, the most obvious answer, it's not always the right one.
Okay, so to get this theory, you only need to know one basic thing. Solar panels? They're electronics. And if there's one thing electronics absolutely hate, it's heat. It's a simple rule, but it's a powerful one. For every single degree Celsius a panel's temperature goes up, its power output can drop by 0.5%. And believe me, under a blazing hot sun, that adds up fast. So the theory goes like this. The sun beats down, all the panels heat up. Simple enough. Now, the panels on the edges might get a nice breeze to cool them down. But what about the ones smack dab in the middle? All that hot air gets trapped with nowhere to go. It basically creates a heat island, just cooking those panels and absolutely tanking their performance. And look, this wasn't just some back-of-the-napkin idea. This was the actual, formal hypothesis from the research paper. They put it in black and white. The panels in the center should produce the least power because of all this trapped hot air. It makes perfect sense, doesn't it? Well, that's exactly what they set out to prove. So to put this very logical theory to the test, researchers took one specific solar farm and put it right under the microscope. All right, enough with the theory. It's time to see what happened in the real world. So their real-world lab was this 5-acre solar farm in Puchong, Malaysia. And we're talking, over 8,000 individual panels? And they didn't just take a few readings. They gathered data from every part of the farm, every single day for a whole month. This was a deep dive for sure. Okay, so this is pretty clever. They split the whole farm up into 12 separate plots. You can see them all mapped out here. This way, they could compare each section head to head, literally minute by minute. The stage was perfectly set to find that hot middle and prove the theory once and for all. But then they crunched the numbers, and they found something that just didn't add up. Yeah, the data had other plans. In fact, it was about to tell a completely different story. And the results were, well, they were crystal clear. The theory was simple. The panels in the middle would be the worst performers because of all that heat. But the reality? Nope. The data showed that all that trapped hot air was not the main factor driving performance. The hot middle theory, it was just wrong. And this map of the farm just lays it all out beautifully. The best performer? That was plot 4, way over on the west side. And the worst one, plot 9, on the complete opposite side to the east. You notice something? Neither one of them is anywhere near that predicted hot middle. The data just blew the theory right out of the water. And we're not talking about a small difference here. This was a big deal. The top plot churned out over 29.5 megawatts that month. The bottom one, barely 25 megawatts. That is a huge, huge gap in energy production. And it had absolutely nothing to do with being stuck in the center of the farm. Okay, so this begs the obvious question. If it's not the trapped heat, what on earth is causing these massive differences? Well, the answer, it turns out, is something we hear in real estate all the time. Location, location, location. It turns out the real key wasn't a panel's location relative to other panels. No, It was all about its specific spot relative to the sun's daily path across the sky, from east to west. Just take a look at this graph. This shows you what's happening over a full day. Each of those colored lines is a different plot from the farm, and you can see right away they are not all behaving the same. As the sun moves from east to west, different sections of the farm light up performance-wise. They peak, they dip, all at different times. It's this really complex dance going on between the sun's angle and where each plot happens to be. The researchers themselves summed it up perfectly in their conclusion. It all comes down to the importance of PV module location with respect to the sun movement. It's a much more dynamic, much more nuanced picture than that simple hot middle idea. So what's the big takeaway from all this? What should we remember? First, a solar farm isn't one giant cookie-cutter power plant. You've got to think of it as thousands of tiny individual generators all working together. Second, each one of those generators has a performance that's totally unique to its specific spot. And that means that designing a really smart, efficient solar farm is way more complicated than just, avoiding shade. You have to optimize the whole layout for the sun's entire journey across the sky, every single day.
And that kind of leaves us with one final big thought. This entire study busted a myth that just seemed like total common sense, right? For a technology we think we know inside and out. So it really makes you wonder, if something as straightforward as a solar farm has these hidden secrets to its efficiency, what other technologies do we use every day that we might be completely misunderstanding?